Charm. You know, we get a lot of interesting articles from ISO, International Organization for Standardization, and they usually have to do with the development of some new standard. Big surprise coming from the Standards Organization.
Imagine that.
And it's not just quality management standards, but technical standards of various types. And for me, it's really these technical standards and what they address that are the most interesting stuff that we get from ISO. And that's because standards are often near the leading edge of technology. They should be. You've got some technology that's burgeoning, it's growing really fast, and now it's like, oh my God, we need some standards to kind of, get a handle around a lot of this. So in this case, we just got an article from ISO titled Precision Farming Takes Off, which deals with a new ISO standard that will cover drones, ISO 21384. The standard is needed actually and pretty important because of the huge surge in drones over the past couple of years. So get this, the total number of US registered aircraft, manned or unmanned, in 2015 was about 260,000 aircraft. So, and keep in mind we're talking registered.
Yeah, a quarter of a million.
A quarter of a million.
Right.
Now, there are more than 750,000 drones.
Alone.
Drones alone, exactly.
Wow.
So just in 2 years, 750,000 drones have been registered. And that's like 750,000, right? And that's just, again, that's just the ones that are registered, because there's a lot of drones that people don't register. You're kind of technically required to register them, but a lot of hobbyists and stuff don't.
If you buy a little drone and a kit or something.
Technically, you're supposed to register it.
But most people don't.
Okay.
They may not, yeah.
So the reason that we're seeing this big explosion in drones, obviously, is that the cost has really plummeted. A good quality drone is pretty much dirt cheap. And this is where the article gets worth reading, because it deals with how drones, because they're so inexpensive now, are being used to reduce waste in farming. So, we talk a lot about lean manufacturing. In fact, we're going to be talking about lean manufacturing here in just a little bit, or one aspect of it. Well, there's also been a lot of lean farming, and it has to do with utilizing only as much, water, fertilizer, pesticides, whatever, as you need. And for farmers over the centuries, this has gone from just treating the entire field exactly the same. You got a big field, you water it, you fertilize it, you seed it, whatever, and the entire field's treated basically the same, hundreds of years ago, right? Then it came around to, well, wait a minute, if I walk the field, kind of like going to the Gemba, right? If I walk the field, look at the crops and soil, well then now I can make some decisions based on my own experience. And so maybe I might treat this part of the field differently than that part of the field, because I've been out there, I can see how the crops are coming in differently. Then eventually we had sensors built into combines and other farm equipment that would measure moisture content, yield, and so forth on the fly. And now we're back up to drones that might fly over the field using multispectral cameras to look down at a variety of crop information and then overlay that information onto a map. Then that information can then be used to custom deliver fertilizer and water and so forth to different parts of a field. So you get the idea here. They map the field using special cameras, and they can tell where that they might need a different type, more water or less water, where they might have some sort of weed infestation problem, where they might need pesticides or fertilizer, that sort of stuff. And then the farm machinery, actually more modern farm machinery, can have this mapping information plugged into it, and a farm machine can literally, as it's moving across the field, custom deliver fertilizer, pesticides, and so forth right at the spots where it's supposed to, because it has this mapping information in it. The farm tractors, by the way, can almost drive themselves. So this information can be gathered actually pretty quickly, and in some cases semi-autonomously. That is, a drone can be programmed with the flight path that it then executes with little or no operator intervention. So all of this has enabled farmers to improve the health and thus the yield of their crops, and do it using less energy and fewer resources, which, if you think about it, is exactly like lean manufacturing. This is kind of that same principle, but using technology to do the same idea in farming, which we kind of think of as just kind of this, you plant some seeds, you water it, and the plants come up, but it's gotten very, very scientific.
Yeah, and productivity, we always talk about productivity in the manufacturing space, but it's even more important really in agriculture. You've got to, we have 7 billion people on the planet.
Right.
You've got to really squeeze productivity out of each acre of land, and this is a solution to do that.
And you don't want to use more inputs than you need.
Especially water.
Yeah,
I mean,
especially water, right,
but I mean,
yeah.
also fertilizer. You know, all the other
Yeah.
stuff that goes into making. Because these days agriculture is an industrial process, and I mean, this is just another step towards that. It's interesting though. You think about it, you're like, all right, drones and farm. You're like, try to think about it. You try to put it together. When you read the article, you understand how those are linked.
It's pretty interesting stuff,
cool stuff. And ISO's on it, man. They understand what technologies and standards are needed to make stuff work for people. So it's pretty cool stuff. Okay.